green button in the bottom right corner.
Perfect. Thank you, Luke. Otherwise, we will be imminently starting. How many people? We've got a decent number. Fantastic. One of the other really interesting ways, and what I hope a lot of you will gain from the presentation, is going to be around how we at Aiimi often structure data science projects, and hopefully a chance to gain some ideas for yourselves, how you can go out and structure your own data science projects, and really having a focus on how to apply these projects to the real world and to real business problems. I think, I can't remember a stat off the top of my head, but a large percentage of machine learning projects end up being fantastic ideas and have real legs and are great models, but without being able to actually apply them back to the business context or apply them back to deployment, then you unfortunately miss out on so much of the value gained. What are we talking about today? So, as I just mentioned, the way we're going to be structuring the talk is how I would go about approaching a data science problem. And we're using the example of COVID-19 at the water industry in order to give some real world context. But we primarily open by describing the problem and understanding from our business partners and from subject matter experts and understanding what their real pain points are. But understanding the problem doesn't actually solve anything. And unfortunately, I can't often just ask my computer to solve the problem. So we then have to abstract the problem. Thanks, James. Yes, before I get full into the chat, James is from Aiimi as well, is going to be answering any questions in the chat. And so anything small as we go along, feel free to message him, or if you want to save anything and pitch it to the whole group or to myself, there should be a decent length Q&A, depending on how long I rattle on for at the end. Thanks, James. Back to abstracting the problem. There's a whole bunch of technical documentation and academic papers on how machine learning problems have been approached, and generally trying to fit something into what's already being started rather than developing something completely new is a good way of actually getting things off the ground. So abstracting the problem into something that you can Google goes a long way when coding anything. Then starting the solution, and for anyone who does code, some of the best things to do is immediately just get down and write some code. Even if you end up ditching that whole lot straight away, just trying things out and working through the problem and seeing what you get out can really help you understand the problem more, and can also help you understand if you've got anything that's going to end up working in the future long term. But as I just said, generally you'll probably want to bin most of that code you originally write, unfortunately, unless you're a much better coder than I am. And for that, we then need to move on to iterating the solution and improving it and stretching it and working out if it can be any better. And I've got a bit more of a technical thing where we're going to run through some code together and talk about how I encountered some quite hefty speed ups, both from an algorithm sense and from a data structure sense as well. So as well as some more of that, how do we structure projects, as well as a very, hopefully quite a technical session on efficiency when coding. Before bringing it back to actually unlocking the value, deploying the solution. And I'll talk generally about deploying solutions, as well as a little bit of some of our specific technology stack on how we tend to deploy solutions at Aiimi or with our partners. followed up by the Q&A. I'd like you to think back to March or possibly slightly different timescales depending on what country you're in. But for us in the UK, it was really March when things were starting to get serious, and the media was running rampant, and the government was changing its mind on a daily basis at that point. But it was definitely a period of real uncertainty, and there was a lot of worries about when it was going to stop, or was this going to be the new normal, and how much was it going to go. And in the UK, we have a couple of reasons that people might be ended up being off and not available to work. A, they could physically get sick, or at the time the government was putting in procedures where if you had any of the symptoms, even without a test, then you had to self-isolate and stay at home for 7 to 14 days. I can't remember the exact requirement at the time, but it was a pretty substantial amount of time. And even if you didn't have COVID, even if you just had a standard cold, you could be sat at home for 7 to 14 days. And this caused a real potential worry about our available workforce. And as a major utility supplier, the water industry has many people who can work from home, like myself, who was able to transition to working from home and who mainly work on the computer or take a lot of meetings, fine. But there are also a lot of physical jobs that require people to go out and do things. And that's not going to work if they're self-isolating at home or if they're actually sick. And these physical jobs or operations can range from mending pipes to replacing a gearbox at a pumping station or investigating an odor somewhere, but things that we physically need to send people out to do. And we call those requirements operations. So I'm going to be talking a lot about operations from here on out. But operations are specific jobs where a technician needs to go out. And these get scheduled by a whole team, and there was a solution in place for scheduling jobs, but it was very manual and required a lot of human interaction, and it didn't scale. So how I'm bringing into AI, and AI for good here, is we're really looking for how do we work out what we can do with job allocation for a whole bunch of different parameters. So we wanted to be able to put different infection curves through. We wanted to be able to start messing with our jobs allocation. Say if it got really bad, maybe we don't actually need to replace that gearbox yet. Maybe that gearbox is going to be pushed back till next year. But the massive leak down the road, that's probably still important. So we wanted to be able to play around with these input parameters, play around with proposed sicknesses, and try and work out exactly when we were going to start to have a serious problem. Obviously, there's the water industry ticks over as it has done for a very long time, but it was really important, as is in the big box, that we don't start to fall behind on water operations uncontrollably. So how did we actually solve this? My key point here in pink, which I definitely stand behind, is the first step when approaching any real world business problem is to understand the as is. And I think this is so important. You've got to make sure you understand how people do things currently, because it's really people who you're trying to push your AI solution to at the end of the project, usually. But you're not going to want to be, I really don't want to be handling job allocation for the next portion of my career. I want to be able to push it back to the people who know what they're doing. And for that to work, I really need to understand the problems that they face. So we need to translate that business logic into a problem that we can solve by computer. And in this case, where we have operations that need to be done, and we have technicians that can do those operations. And abstracting that problem turns into a queue of demand, operations that need to be done. The first one, then the next one, a less important one, all the way down to something that we're probably not going to get round to for a very long time, as well as a pool of resource. And this pool of resource, in this case, resources technicians, and when they're available to work, if we're available to send someone out to do an operation, then that technician is a resource. It's quite an inhuman way of looking at technicians, unfortunately, but it does describe what they're doing really, really effectively. We are going to skip over what I think has been described in data science as 80% of the work often. And that's the data engineering that unfortunately you need to get to your clean data set. The data engineering here is quite client specific. It's specific to the water company we're working with, and tended to be more about making sure we got the data we needed out of their systems, brought it in, cleaned it up, formatted it correctly, removed some of the aberrations, all of the standard data engineering stuff, which I'm sure you've seen before, or there'll probably be more sessions running in the future. But we're going to assume clean data, which is a pretty big assumption, but I think it's fair to make it because we've only got an hour session. So I've got two data tables here. I've got one on the left we're going to look through first, and this is our queue of demand. So every single row in this data table is an operation that needs to be done. So the top one might be fixing a leak, and the bottom one might be, I don't know, I can't think of anything horrendously unimportant, but maybe it's cleaning up a spill on, this seems quite important. Maybe it's refreshing the paint on a sign outside outside the office. It still physically needs someone to be done, but it's much less important. So we generated a calculated priority based on that business logic. So we were able to take all of the metadata related to these operations and assign them a value of 1 to 52, I think, judging by it, sorted by that. And that allowed us to organize our list into the order that we should be working on. Each of these jobs have a required skill. We don't send the same person out to change the gearbox as we send to paint the sign. And the required skill can be described by a number of letters, which are, again, an abstracted set of skills. It doesn't necessarily matter what each of those relates to, but it's a skill requirement. The current hour of year, HOI, is a metric which we might chat about later, which I seesaw on a few times whether it was a good idea or a bad idea. But at the time, it keeps track of the hour of year that the simulation is running through. So we can't do a job if it hasn't already existed. Because this queue of demand also looks into the future, it's a forecasted queue of demand. If the job hasn't actually happened yet, we can't do it. So we need to keep track of which hour of year the simulation is running at, so that we can't do a job that hasn't actually occurred yet. Obviously, again, another assumption is that the forecast isn't going to be completely accurate, but we have a few different things that we can play around with, some of those levers I mentioned earlier that allow us to edit the forecast and sort of had a best case, worst case scenario, or a few different scenarios for the upcoming profile of work for the next year or so. Total work is the amount of work in hours that it's realistically going to take a technician to do. So that would be how long it's going to actually take them to complete the job. And some jobs are very long, some jobs are very short. Even in that thing, they vary between 3 and 27. I would just say that's a fairly sensible range, having played with the data plenty. Most jobs are, you can do it, some jobs you can do a couple of jobs in a day. Other jobs, you're going to have to send someone out for 3 or 4 days. But it's rare that we're getting an extremely long job of the hundreds of hours of work. If so, that would generally be broken down into smaller jobs. And our incoming hour of year is the hour of year. So in this case, it really should be a date time, which is where we get to the should I have just used date times discussion. But when did the job actually arrive? That high priority job is evidently very old and arrived a few years prior to the simulation starting, whereas some of the ones at the bottom haven't actually occurred yet and will be forecasted jobs. That was our queue of demand, and we now have to consider our pool of resource. So our pool of resource is looking at each of the individually skilled technicians. So across the top, we have 10 different letters that relate to the skills of technicians. These don't map one-to-one with the generic skill required for the job. Where possible, we would match the skill of the technician to the skill required of the job. But if we fall into a situation where we don't want to give up on a job too quickly because we don't have the appropriately skilled technician, we might use a differently skilled technician to do a different job. And that's one of the levers that you can start to pull to control how, in a COVID situation, maybe you need to start sending your specifically skilled technicians to do less skilled jobs if they're really important. And that's abstracting the problem. The table on the right, I think it is worth mentioning, it is all zeros because Pandas takes the top 5 rows and the bottom 5 rows. And unfortunately, during the day, the day starts at 12 AM and ends at 12 AM. And the area that we're working on doesn't have 24-hour technicians. I'm hoping later we'll see that there is some actual technicians, but what you'd see in the middle of that table would be a 1 if we had 1 technician available to work at that hour, a 2 if we had 2 technicians available to work at that hour of that skill, and you can also have non-integer technicians if, say, a technician is on a lunch break or doesn't start at a certain time of day. So 1.5 technicians is still a valid thing, but they're only going to get half hour of work done on the job. So this here is writing a pretty basic algorithm to start off with. And I do think it's worth saying because it's not a super complex machine learning algorithm or AI that we actually implemented here. And honestly, that's not a problem. I think there's been a real trend recently towards AI explainability and being able to really relate AI back to a business problem. And working in the language in this circumstance, working in the language that that the business users already use was more important than having a black box that was 100% efficient. For this problem, if we could get 90% of the way in a way that people were confident about, especially during COVID, that was plenty sufficient enough. So really, it was more about trying to use artificial intelligence to replicate the human solution rather than do something completely revolutionary. And that's honestly a perfectly good use of AI as well. Replicating humans and being able to do more than what a standard human can do is still fantastic. So our algorithm, real basic. This was the first one. It took me a pen and paper and a few minutes of looking at the data to figure this out. Can we do the top row? And when I say can we do, we need to check for a job, which is our most important job, row 0. Do we have a technician available at the correct time of day of the correct skill? If so, we can do 1 hour of that job, and we can, or do around 1 hour of that job, and we can do 1 hour of work. And that's great, and we can then restart the loop. If there's no work left on that job, then we can remove the job, count as completed, we can resort the list, and we can find our next important job, and we just loop it around and keep running. If we can't do the job, because we don't have a technician available of the correct skill or of the correct time of day, then we need to push the work back an hour. We need to push the current time of the work back 1 hour, and then check if we can do the next job. So we resort the list, we find our next most important job, and then we work it out. And little thinking exercise. Can anyone see any massive problems with this algorithm? I'll give you a hint, it's not very good. But this is where it's great because we can improve it. There's two real major problems with this algorithm. Everything ends in resorting the list. And I don't know how much coding some of you do, but sorting a list isn't necessarily fantastically efficient, especially when it has to be done every single time your loop runs. As well as a quite major problem over here with pushing the work back an hour, where it means we have to actually look at every single row every single time. So if we were never able to actually achieve any work, we're running the simulation here for approximately 2,000 hours, and we're having to check 1,500 rows here. So I know some of those work out later in the year, and are forecasted later, but let's say approximately we've got 300 or 400 times going. You're having to do that check for every single row, and already with these quite small numbers, that ends up being, back of the napkin figure, 2 million checks. It's not a particularly efficient loop. We can improve it. So what you might have seen I've done here is we've realized that if we complete job, our list was already sorted. So if we complete the most important job and remove that from the list, what's behind it must be our second most important job, and hence our new important job. So we can resort that list, or sorry, we no longer need to resort that list, and that's going to save us a whole sort every time we actually successfully complete a job, and that actually ends up being quite a lot. The other massive time saving is over here, where previously we checked every single element in the list. But if we failed a job of specific skill at a time, then that also means we must have failed all other jobs that are also relevant at that skill and that time, even if they're less important. So anything in the list that has a skill of, say, E, and is set to be looked at currently at hour 2136. That means that we can fail all of those simultaneously. And all of a sudden, that's massively reduced our number of loops that we have to go through. I've got one last optimization. You could do this quite a lot. There's definitely something there if you're a better computer scientist than I am later, and I'd be interested to hear any thoughts anyone's got. But we also don't need to keep everything in one data structure at once. So when we're sorting lists and searching lists is dependent on n log n, order n log n for sorting, I think. And searching is at worst n, I think. But if we can reduce the number of rows in that data frame, then that helps us out. So this right here means that we only need to add in new demand. We only need to add things into the queue once they've actually become feasible to do. So I spoke about earlier about when we forecast jobs, that if we forecast things, then they don't actually have to be, they can't be done yet. So we can add those in later. We've done a lot of talking. So to avoid death by PowerPoint, I'm going to jump us to Google Colab, which I've had recommended to me before, and I would recommend as well for to other people for a notebook environment. And I will quickly take you through some of the code I wrote and see if you guys can apply any of it to your own projects. Started off really simple. I should say, it's not a given, even though a lot of people do use Python. I'm primarily a Python user, There was a few cases when I considered jumping to something else more efficient during this project, but honestly, if you write Python in the right way, it can be pretty efficient. It's got a huge selection of machine learning packages, and it's really good. Again, we abstracted the problem, so you could try and solve this problem in any language that you wanted to. With Python, we need to import a pretty hefty selection, not that hefty, but a selection of packages that are fairly standard. And I've preloaded a demand and a capacity into pickle files and uploaded them to the workspace. So let's have a quick look. So demand, I think, is going to hopefully look quite familiar. I think because I took it from here. So as we can see, we've got demand. We've got about 1,400 rows loaded in. And
hey, Reece.
Yes.
I think can we zoom in a bit? I think a couple of people have asked if they if you can, because they're having a bit of difficulty. Is that better?
Is that better?
Looks a lot better to me.
Yeah, of course. If you drop me an email later on, I believe I'll have to double check there's nothing confidential in here, but I should be able to send code around later as long as it's abstracted fully. So, or I could run through some things afterwards, but I'll pass that on later at the Q&A session. So we've got the capacity table we've seen before. We've got some functions that I'll breeze over a little bit, as they tend to be more specific to the problem we're solving and what we actually wanted to output back to the business. Having a fantastic algorithm that doesn't tell anyone anything isn't actually any useful to anyone. So we have some functions that interpret the simulation and actually do some outputs. Of possible interest is this lookup here, which relates our technician skill back to the possible work skills that they can do, and that will just loop through. We have a function, useTech, which looks at our capacity and gets called when we actually try to use the technician, and can either return 0 if we have failed a job, or can return the amount of work that gets completed if a job gets done. KPIs, as I alluded to earlier, these are to push things back out to the business when they want to see what the results are, and the ever punishing hour of year needs to come back to a date eventually, so people can actually read that. And run that one. So this is my main loop that runs the actual algorithm. And this is not the first draft. The first draft was significantly longer and had a lot more stuff in it. But this is a cut down version, which should be indicative of what actually happens, and back to that basic loop that we looked through earlier. So a single while loop, I think, that we run through. If it's an interesting time of the year, we want to generate those KPIs so we can push back to the business. Other than that, we assess some stats from our top level of our demand. We attempt to use a technician on that demand, and we see if we actually have successful. If we are successful, then we want to increase the hour of year by 1. We want to push that demand back an hour, but also remove the amount of work we completed on that operation, so that we actually start to complete operations. And I believe as part of the use tech, we remove the technician from the capacity as well, because we don't want a technician being able to do every single one of the jobs. Once he's done a job, he's used up for that hour. And if we complete the job, then we can drop it. We can remove it from the list, then we resort the list with old pandas.sort values, and this works. If we pause for a second, it will run. And this was a pretty basic but effective algorithm, and it was pretty basic because we really wanted something running in about a week once COVID really started to ramp up. So you can maybe see the fact that it's still running, that it maybe even with some of the algorithmic improvements that we made, maybe it wasn't great. So I'm going to continue to fill time. I think this is about a minute, I say bravely, but we've already made some algorithmic improvements. Anything else would make the algorithm significantly larger and more complex, and you're not going to be able to explain it back to your business context. So what else can we do? And about here, I start to think maybe Python wasn't the coding language for me. Maybe it was time to eventually and finally learn to use Rust. Maybe not. But we need to iterate and improve on our solution. We'll let that continue to run. I don't know why it's still running. I thought it was about a minute, but we'll find out. While I go back to the PowerPoint. So we need to start thinking critically about our data structures. And the algorithm is too slow for a large amount of open work. It's definitely too slow for one of the things that was requested at the time, which was, can we have a nice web app that allows us to change all these input parameters, put in a different curve, and see what happens when we hire more people or we lose people. It's not going to work. We need to reduce the runtime from the order of minutes to the order of seconds. So we can profile our code, and I'm not going to attempt to teach you to speed up your code in general, because there's definitely people much better at that than me. But there's two things I'd like to chat about. Is pandas actually really bad? Which is a little bit of a specific Python question, but a lot of machine learning is in Python. So pandas is one of our packages that we use to control data frames. Is it actually bad? And that's a very controversial subject, and I'm still not sure whether the answer is yes or no, or whether it's one of my implementations of pandas. But there's that, as well as thinking about dictionaries versus lists. And even though this is specific to Python, I again abstract that out to thinking about what data structures you can use in programming languages you have access to. Hey, we're complete. So if we have a look at one of our output queues, we can see that we've mostly stayed on top of jobs. We only have one high priority job that came in 7 hours ago. So we're staying on top of our high priority jobs, and we've got a whole bunch of, we've got 200 low priority jobs now that we need to work through. So pretty good, but it was really slow. So can we improve that? So we've seen this before, importing our packages. Now, rather than keeping things in a pandas data frame, why don't we, and pandas is very clean and it's very nice for actually looking at and exploring things, but why don't we start to think about how pandas actually reads and writes from it? So when you're reading and writing from a pandas data frame, you need to loop through the data frame to find the actual index and the memory location that you're writing back to. And that's pretty inefficient, because it means that writes are pretty slow. So writing directly back to a pandas data frame, at least how I usually do it with a .lock, isn't very efficient. And I feel like there definitely must be a more efficient way. But a little bit of Googling didn't help me out. And generally the old recommendation is to obviously vectorize your loops and all of that. I actually replaced the pandas data frame with a simple list of lists, which is a 2D array that keeps track of what we're doing. And the important thing here with this 2D array is there's much less overhead with metadata and keeping track of that. And it means that I can address that 2D array directly, and I can pop off the end of that 2D array very efficiently. If I was to add something into the start of that array, we would we'd unfortunately have to shift everything back. So when working with lists, at least in Python, you generally want to be trying to work at the end of the list, allowing you to add things on or remove things quite efficiently. The other big time saving was looking up and writing back to this capacity. And this capacity could be converted to a dictionary in this case. So when we're working with dictionaries, we have an exact memory location, or near enough abouts. I don't think Python has pointers in the same way something like C would, so we maybe can't reference the memory location exactly, but we can reference an exact location in the dictionary, which means we can, when we want to look up if a technician of skill E is available at hour 2500, we can do that straight away. We can narrow down directly to that point. So again, the code is much the same. It still does the same thing. It still does the same algorithm. It still loops through. It still checks to see if we can complete the job with our tech. I think it even uses much the same new tech function. It's the same algorithm, but it's working on different data structures. And that look of different data structures means that the code now finishes in that length of time, 3 or 4 seconds. It's the same algorithm. And I really wanted to just do this whole section here to demonstrate that once you've completed your first draft, think critically about your implementation of it. You can find some generally quite quick speed ups. I'm sure someone better than me again could probably speed this up maybe another 10 times, but this ended up being fit for purpose. And that's fast enough, but you can really actually achieve some great things. I'm not going to show you what we actually pushed back to the customer, but as an example, this is our total size of queue, I believe, as we go, and we can see at the parameters that we put in, generally our size of the queue oscillates between 10 and 30, but it doesn't get any worse. So in this COVID scenario, we're staying on top of our job, and there's a whole in the full code. There's a whole bunch of different parameters that you can change that allow you to put in different curves, and you can see whether we start to fall behind or get ahead. We'll be moving to a Q&A briefly, but I wanted to go back, avoid the code a little bit for anyone who doesn't enjoy permanently doing code, and talk about actually recognizing some of that value. We used Databricks, which is a company that works with Microsoft in the Azure stack to deploy our product. And when I say deploy, I mean, how do we use this algorithm, and how do we push it back to the business so they can actually use it in their day-to-day? So what have I've said so many data science projects never see fully realized value due to not having a deployment strategy. So I think I'm leaving you with 4 points here to think about. Focus on your input data and your data engineering. Consider how you're actually going to get access to that data, how often it's updated, and who's in charge of making sure that data doesn't drift or doesn't come in with aberrations and stays clean data. And think about your processes for that. Understand your technology stack. There's a lot of companies out here selling whole new stacks and whole new tech for one problem, and that's great. A lot of them are really good. But if you've already got a technology stack, often you're able to achieve what you want to do with your existing technology stack. Luckily, I'm not paid by anyone trying to sell us a technology stack. But you can often make the most out of your Azure subscription, or your AWS subscription, or your Google Cloud Platform subscription, or a tool like Insight Maker that Aiimi produce. You can really find value in what you've got, and often thinking about what you can do and what business problems you can solve, that's going to unlock more value for you, bringing in someone to look at your actual business that just buying a brand new product might not do. Consider how the end user is going to view your data. handing someone a Google Colab notebook in the business and telling them, oh, I've done the job, doesn't necessarily fly. We ended up using Power BI to push the results, those KPIs that I alluded to earlier, back to the business. And that was great because it's in a format they use, it's in graphs they can already work with, and that's how they actually consume the data. They don't want to consume a machine learning model on the cloud somewhere that they can't see. Maintenance as well, maybe slightly less relevant for COVID-19, as the problem, while still here, isn't as worrisome as it was back in March. But consider how you're going to keep upkeep of your data science model. You may want to make sure that you've got some automated things that update you on the health of your model, or make sure that your users are actually using it still. And often we're going back to your users 3 months down the line. There's often a quick little wins that you can do that unlock a lot more value for them. Well, thank you very much. We're going to move over to a Q&A. I see the chat has been fairly active. I hope James has been answering questions for you quite well. But if anyone has got any questions, we can. I'm happy to take them now, or open a discussion between the group. Or if you don't fancy telling me now, you can email me at rcook@aiimi.com, or there is a LinkedIn link there. Also, hopefully you'll be able to find me at the Aiimi Hackathon on August the 24th, I mentioned earlier, where we're working with a number of water companies to solve 4 problems in the water industry. You don't have to be a water industry expert or a leading data scientist to join. Opening to the room.
Well, thanks very much, Reece. Great presentation. We did get a few questions that I wasn't in the best place to answer. So Henry asked a great question. If you want to take the floor, Henry.
I can scroll through and find his question.
Yes, oh, sorry, I was just wondering how you can handle the travelling time between jobs.
Teleporting technician problem.
Yes.
Yes. That is actually a major assumption. So you don't want to abandon a job once it's started, but that actually does happen a decent amount in the real world, where if a high priority job does happen, and if it's not a job where they need to do reinstatement, such as putting the road back, then they actually will switch between jobs or reallocate resource on the jobs quite rapidly. So it was something that we spoke a lot about it was something we spoke a lot about with the business customer, but they decided that they'd rather have the ability to see their highest priority work, particularly in a COVID situation, than have to lock in a technician for the entire job. That wouldn't necessarily be true in real life. So it is an example of why I haven't actually replaced the entire department. The department is still very useful, and this is a supplemental tool to their work, but it isn't actually going to solve. It's not a scheduling tool that you would use to actually schedule. It's more of a view of the different scenarios where that's an assumption that we chose to make. How long have I been a data scientist? I've been a data scientist for 2 or 3 years. I was originally a proper scientist by education. I was a chemist or a physicist, and switched over to being a data scientist shortly after giving that up. But it's been a really good journey, and I think there's a lot of resources out there at the moment that you can learn from and learn with. And honestly, a lot of that logical thinking, that being like I say, a proper scientist, working in a lab or that sort of side of things, means that you can apply that in a lot of cases. Anyone else? Any other questions from earlier on?
Ryan Odell asked a good question as well in the chat. I can quickly read that out. Wouldn't you look at the skills currently available and select the highest priority task for each of the available skills or workers?
Or doing it from the vice versa. So
exactly,
iterating, iterating through the available technicians and then looking at the jobs. Yeah, it is a pretty good way of doing it, and it's something we considered at the time. The problem we had with that is that we often want to take snapshots for KPIs at times that we may not have a technician available. So if we're looping through the technicians, we're going to gain time savings by not having to check every hour, but we're going to lose the ability to, say, view what the situation was at 4 p.m. on a Sunday, because we don't necessarily have a technician there. One of the things that I looked into that I didn't end up running with was using a package called SymPy, which looks to use generators and yields to assign key times that the simulation to jump to, which means that we're going to save times of looping through the night by making notes of when you have a next available resource, which definitely would have been an algorithm speed up, but at the expense of algorithm complexity. So we didn't end up running with it because of the quite tight time constraints, but I would have really liked to try SymPy, or I really also would have been interested to see the speed of looking at it from the other side, from a technician side. Yep. Anyone else? We've got about 5 minutes.
Okay. So Urek and James also commented a couple of interesting points about replacing pandas in projects, and James posted in the chat about another tool in Python to work with large data frames called Vex. I think I might have pronounced that wrong, but if you're still here, James, that'd be really good to hear a bit of maybe discussion about.
Yeah, that'd be really. It's not one I've heard of before.
Yeah, sure. I've not used it directly. It's something that I've always been aware of, but I've never had to use it because I've never been in that position. But I know other people who've used it, and it seems to be very helpful. It might not be directly applicable to you, but it might be something that would be useful later on. They certainly have really nice ways of the fact that it seamlessly slips into scikit-learn and all of that stuff.
Fantastic.
And it's really good if you've got billions of rows and that sort of stuff. It might be quite useful since that's what it seems to be aimed at. So it might be quite useful for you guys, at least in the future, maybe.
Yeah, it'd be really. I'll make sure to check that out. We do some of our work, and this actually, the deployed solution ends up running on a cluster as a mix of PySpark and straight up Python. So this has been decently parallelized as well. And PySpark tends to be our go-to solution for high concurrency data sets, but then you need a full cluster to, did I use PySpark data? I'll come back to you in a second, Jack. Then you need a full cluster, basically like a cloud suite, unless you're way better at setting that up than I am on your local computer. So tools like that sound really great. I'll definitely check that one out. Did we use PySpark data frames? We do use PySpark data frames, Jack, to keep track of the larger data set. So one of the things that we were looking at the moment was one very specific work center, but our water company has hundreds of these work centers, so we actually need to run this algorithm hundreds of times. So for that, we then keep all of our data in a PySpark data frame, and then we only call to the pandas, or no longer the pandas data frame, we only call to the Python data structures as and when we require them, which means that we keep the efficiency of PySpark data frames for all our data engineering and pushing back to Power BI at the end.
Thanks, Reece. Are there any kind of other final questions?
Yeah, about data science in general, or about the project?
Sure. If you had any questions on Aiimi as well, we'd be able to answer them.
Yeah, of course. Of course, that's a good one.
Hello, I'm going to chip in with just a random snippet of knowledge, if that's all right.
Yeah, Jack, feel free.
Rather than type it out, just to further develop the PySpark data frames stuff, for anyone using Databricks specifically as a platform, which is a really good platform, by the way, that these guys have used at the water company. Sorry. And it's available both on the Microsoft Azure stack as well as the AWS stack. And they've actually recently, Databricks, they're the company behind Spark, and they've released something called Koalas recently. And Koalas is a sort of a wrapper, I think is probably the correct term, for PySpark data frames that's designed to make them behave a lot more like Pandas would. So you can actually take code that you've developed locally on your laptop in Pandas and translate it to work on PySpark on much larger data sets really easily, really, with a change of import. So it's definitely something, if you are using Databricks or you're interested in using Databricks, it's worth checking out.
Yeah, really cool. It is really cool working on a cluster, definitely. But you do sometimes lose some of that magic of running something locally on your laptop, and it no longer feels, when you're working on a cluster, it no longer feels like you're building something in your garage anymore. We have 2 or 3 minutes left before we're leaving to go back to the main session. So happy to finish it there, and anyone else can grab a drink before going back to the main session. My email is rcook@aiimi.com, or you should be able to find me quite easily on LinkedIn rather than using that link. Feel free to get in contact with any other questions or anything that Aiimi might be able to help you with. Or again, we're running a hackathon on the 24th of August, and we'd love to see any of you who are interested there. Thank you very much, everyone.
Thank you very much, Reece.
That's okay.
Thank you, Reece.
Cheers.
And I just wanted to add that I've added the link for the videos in the chat. So tomorrow, people will be able to see all the videos.
Brilliant. Thank you
Yeah.
very much.
Thank you. Thank you so much. See you in the main room.
See you in the main room. I don't know if I can force close the breakout session, but it's looking like the leave room is going quite well.